So now I have the pleasure to welcome and invite on the stage Paul Kruczewski. Paul is the CEO of wrnch, and he will talk about how he's using deep learning to teach cameras to read human body language. So welcome, Paul.
Thank you, Sasha. Over here, and then I'll click. Okay. Super pleasure. Thank you, Sasha. Thank you, Autodesk, for organizing all this. I don't know if you're aware. I mean, this really is the ground zero of computer graphics in the whole city. This and Softimage. We're really here, and it's really cool that the ground zero of that is the ground zero of machine learning. Let's see if this. Myself, I came here. I'm from Alberta. Came here for PhD at Montreal, McGill years ago before most people were born. During the AI winter, so I did algorithms instead. Started my first video AI company in 2000 called AI Implant. Back in the day, that was large-scale agent simulation. So how do you simulate thousands of stupid things? Did it for movies, games, and military. Got bought by CAE. Started another company called Grip Entertainment, 2007. How do you do small scale simulation of, let's say, 10 agents, but in highly kinetic environments? I.e., how do you simulate Navy SEAL squads? Bought by Autodesk. Thank you, Autodesk, for that. Took a sabbatical in molecular biology in the UK. That exposed me to scientists, and started wrnch in 2014, 4 years ago. We started as an image processing company, denoising, sold it to Hollywood, built the Jedi AR headset for Disney. We did the tech stack for that. The last 2 years, we've been working on this, what I'm super excited to talk about. So, there we go. So let's flash back. When this building was built, that's Bill Gates, and, there you go. The dream, right? Computers that understand us, not through keyboards, but they hear us. And you know what? It's a great time. We're building the future, all of us together. I love that. So what if cameras can read human body language? Let's think about that. And I think it's important to really think about the applications first. I know I have a PhD, lots of researchers. We like to tackle problems because they're cool. But at the end of the day, we need to build things that, build a better world. Simple as that. So my maternal grandmother, she used to live alone, and every day my mother would come visit her and make sure she's okay. And then the one day that she doesn't come to check up on her, she has a stroke. And she left. She was lying there. That's not my grandmother, and we're not going to go crazy here. But, this is important. Society is aging. People want you. How do you balance society aging with the fact that we all want autonomy, right? I want to live in my house as long as possible. I think we all do. That's very normal. That's a great thing about the society we live in. So, how can we, if intelligent assistants are coming, I think it would be amazing if, we can detect if people fall in the house and it calls 911. No one's going to wear this tag around their neck like, I fell, Building on autonomous vehicles. Again, especially in Montreal, it's a little wacky driving in this town. It's a little wacky being a pedestrian in this town. But when it works, when it works, there's a constant dialogue between hopefully there's a dialogue between the drivers and the pedestrians, right? As a driver, you should be looking at the pedestrians and watching, are they going to cross or not? And they might be signaling, hey, I'm crossing, wait, I'm freaked out. And as a pedestrian, you should be looking at drivers too, but that's a different issue. So it's really important. Right now, the state of the art is effectively a bounding box. You are just a rectangle to that car. It just knows that do not kill. That's the level. But we need to interact with cars. I think that's very normal. Again, healthier, right? If we can, we all work a lot. We're sitting a lot. Who wouldn't want a personal trainer on a mobile phone, right? Also, we're all busy. Who doesn't want to walk into a store and just pick up the stuff and leave? Again, if we can train cameras, we can do this. Robots, I really like that from Autodesk. I think they sponsored this really beautiful video once of this artist who's got some kind of mocap system on her body, and he showed it where they're sort of interacting with the robot. I assure you, robots are coming They're everywhere, and we need to interact with them in a human way, right? Again, right now we're a building blocks. Why wouldn't you want to be able to interact with a robot high fidelity? Why wouldn't you want to be able to say, hey, come, stop, go around? This is all happening. But the fun thing is, again, one technology is core to all these problems. The science is called human pose estimation. This is Edward. That's Maggie. Maggie used to work at Autodesk. She ran the game engine team. And there we have it. We've got a camera on a phone, and it's tracking Edward in real time. So how we do this is a mashup of human pose estimation for the scientists, deep learning, obviously. And I'm going to really shout that out, that in your engineering teams, if your instinct, especially if you're a manager, if your instinct to solve a problem is not deep learning first, change your instinct. Seriously, do not use heuristics. If you always, if when you're solving any problem, ask yourself, is there data? Can I make data? Can I turn this into a deep learning problem? I kid you not. It's really important. This is groundbreaking. I got religion 2.5 years ago, and I can't stop. But the other interesting thing about this problem is, and I'll say this very seriously, I think what's unique about Montreal is there's this great mix of computer graphics people. I mean, think of what's happened in this building in terms of visual effects. Think of what's happened at Softimage, Cadera, in terms of 3D animation. I'm not even talking about the game side, just the fundamental tools. And, I see a lot of computer vision people ignoring computer graphics techniques. I see a lot of computer graphics people, frankly, doing bad computer vision. We are blessed in this city that there are experts in both fields. We need to talk more, and I really love this and that's what we do. But again, maybe the difference between a research organization where your ultimate deliverable is a paper, we're a startup. I put money into this. Mark Cuban put money into this. We need to pay our people, and the only way we pay our people is by shipping hardened software. So I think it's really important to never forget this: software engineering, actually making releases that are QA'd. That's super important. Why is this happening now? You may or may not be aware. Why is it all of a sudden why are we out of AI winter and stuff? And again, I say thank you, games industry, for this because, well, number one, cameras everywhere. But if it was not for GPUs are a peace dividend of the console wars. Nvidia, Sony, Microsoft spent billions of dollars building these beautiful GPUs. And that only became possible because of the game industry. And we're lucky. We get to use that for deep learning. So thank you, game industry, for that. But just the alternatives, what we're trying to do is we're trying to allow cameras to understand people. Obviously, there's alternatives. I'm not saying they're bad. You can go all super high fidelity. Is that laser? Oh, look at that. Awesome. Laser, clearly Vicon. That is the state of the art if you want the best. What's the problem with that? Well, it's really expensive. You got to set it up, and you got to wear a funny suit, right? That's no funny. Oh, there's Kinect. Yeah, I mean, that's a $500 million research. It's awesome, but if any of you have built a Kinect game, it works in your living room with the shades closed, and it's big, and you can't buy it anymore. But, Atomic Lab's a great company out of Ontario, and, they've built a very cool sensor that you put on your wrist. I think it's an excellent thing, and it's part of the solution for sure. But again, not everyone. There's different times where you don't want to put things on your wrist, so on and so forth. So it's not saying Leap Motion again, a great sensors, but software again, probably because I'm a software person, so I think software is the best. But software is amazing because if you get it right, and you've probably seen in your own systems, it's always getting better. Hardware is fixed in time and space. It's done. So it's great, maybe low power, maybe you can, ship lots of units at low cost, but it's done. It's not going to change. That's the beauty of software, living and breathing. So I'm just going to go really briefly over the how this works at a high level. Again, the human pose estimation people in the audience, sorry, but I'm just trying to keep it simple here. That's Maggie, that's James, they work, and what's going on? How do we get them to understand that picture? Well, we do it from a bottom-up perspective. We've taught the computer to recognize key points, right? Here's 21, no left toe, left ankle, left eye, right ankle. And we've exposed to hundreds of thousands of images of these key points. And so what we do is we glue these, we first find all these points in this image. And it's a little like teaching your kid, to read the ABCs. Lots of repetitive, read the same story every night. But from that, we can start to glue, that was supposed to stitch them together. Anyways, you can glue them into individuals, skeletons. And there's a demo over there, I can run it later, but, James, Maggie, individuals. There, now we finally got it. But then once you get the skeleton, this bottom up, then you can start to infer gestures. What's really going on in the scene? So here, James is touching his chin. Maggie is holding something, right? Then finally, we can say, well, James is thinking, and because we know the context of the objects in the scene, Maggie's actually filming James with her phone. Now, this is half true right now, half works, but we're on a clear path to solving this problem. So that's what we mean by reading body language. Okay, so really jumping very briefly into the tech stack, 2D out, all this knowledge in, segmentation, background segmentation, green screen, effectively. So we kick out 2D skeletons, 3D skeletons, IDs, locations, gestures. Just ram-packed with deep learning everywhere, as I said. We've got, in the pose estimation, we have a 2D pose estimator that gets the whole scene. We have a 3D pose estimator. Here, we're working on a very complex gesture recognition system, an activity recognition system. Tom's in the audience here, one of our guys. He's working on that. Fortunately, can't tell you much more than that because it's for a client. But we deploy on TensorRT. We find really, they've been great. NVIDIA's been great. So if you're not using TensorRT as an inferencing framework, I would consider it. The support's been fantastic for us. But we do have it running on the neural processing engine, that stands for. So training pipeline, again, data. I hear it. That's all my scientists say every day. We have an interesting mix. And again, going back to the game industry. So here, standard databases that are available. We've augmented them to add toes. We've also now, it's the data flywheel. Now that we work on a lot of projects, we're profitable. We get a whole bunch of data from all kinds of things. We annotate the data ourselves. We have data people inside. We generate our own data. But, I see actually one of my old friends, JP from Montréal Virtual. I don't know if anyone else from Montréal Virtual is here, but, we were doing virtual humans in 1998 in Montreal. So we, in this case, we use the Unity game engine. We generate a whole bunch of virtual humans, get beautiful ground truth, pump it in here. The state of the art, I think, for human computer vision is a mix. We're not there yet. We don't have the resources that Ubisoft has for photorealistic humans. A lot of respect for that. That's hard. I've worked on that. So we've done about an 80% real world and about a 20% synthetic world, like that. And obviously we're, want to do all the good things for the world, but let's have fun. This is Montreal. I love this town. We build fun things here. So this is what we just showed at South by Southwest. We call it the Magic Mirror. That's Andre. He's, so basically markerless motion capture, and you dance in front of it, and you're transformed into an avatar. We would have brought it here, but we didn't. So there you go. Like everyone, we're hiring like crazy. Come join us. But on the other hand, there's a lot of cool teams here that if they want to use the tech, it's shipping. So we're shipping too. So shoot me an email. Glad to let you use it. That's what we built this SDK for. And there's the crew. All right. Thank you very much.